In today's session, we are going to learn about finding the general solution of a differential equation using variable separable method. Hi, I am Syed. Welcome to my channel Educate with Syed. Let's get started. The first question is, find the general solution of the differential equation dy by dx is equals to 1 minus cos of x divided by 1 plus cos of x. Let us try to see how to find out the general solution of this given differential equation using the variable separable method. So we have this differential equation dy by dx is equals to 1 minus cos of x divided by 1 plus cos of x. We know this formula is cos 2x is equals to 2 cos square of x minus of 1. Now if I take this minus of 1 on this side, it becomes 1 plus cos of 2x is equals to 2 cos square of x. But suppose if I try to replace this 2x value by x. So if 2x is there, you are getting x. If you are having x, then it becomes a half angle. Then x will be replaced by x by 2. It becomes a half angle. Therefore, 1 plus cos of x will be nothing but 2 cos square x by 2. Similarly, we have one more result. Cos 2x is equals to 1 minus 2 sine square of x. If I get this minus 2 sine square of x on the other side, it becomes 2 sine square of x is equals to 1 as it is. Send this cos 2x on the other side, becomes minus cos of 2x. So once again, if I try to replace this 2x by x, so here it becomes a half angle. X will be replaced by x by 2. Therefore we have 2 sine square. Therefore we have 2 sine square x by 2 will be equals to 1 minus cos of x. Therefore 1 minus cos of x is nothing but 2 sine square x by 2. Now let us substitute these two values, 1 plus cos x and 1 minus cos of x values, in this given differential equation. So we have dy by dx is equals to 1 minus cos of x is nothing but 2 sine square x by 2. This whole divided by 1 plus cos x is nothing but 2 cos square x by 2. We see that this 2 and 2 will cancel out, and sine by cos will be nothing but tan. So therefore we will be getting tan square of x by 2. So we have dy by dx is equals to tan square x by 2. Now let us try to separate the variables, which means we will try to get x on one side and y on the other side. So here tan square x by 2. So x value is over here. Send this dx also on the other side. Just cross multiply this one. We get dy to be equals to tan square of x by 2. I'm just cross multiplying that one. It becomes into dx. So you can see that the variables are separated. Y is on the left hand side, x is on the right hand side. Now let us try to integrate this one. Integrate on both sides. We get integral of dy is equals to integral of tan square x by 2 times of dx. So we can't just integrate tan square x by 2. So we'll just try to rewrite this tan square. So tan square can be written as secant square minus of 1. So tan square x by 2 can be written as secant square x by 2 minus of 1. I'm just using the basic trigonometric formula for tan square as secant square minus of 1 times of dx. Now let's try to integrate. On the left hand side, integral of dy will be y is equals to, try to apply the integral for each of the terms. It is integral of secant square of x by 2 into dx. Again apply the integral, it is minus integral of dx. So we know the integral of secant square will be, so we'll try to use the basic formula, that is integral of secant square of ax into dx can be written as tan of ax divided by, we'll try to see the coefficient of x. So what is the coefficient of x over here? A. So divided by a plus the constant of integration c. So that's the integral of secant square ax. So here if you try to observe the value of a, so in this case your value of a is what? Coefficient of x. Coefficient of x is 1 by 2. So a is nothing but 1 by 2. Therefore if you try to use the formula, it is tan of ax, that is x by 2 whole divided by a. So a value is 1 by 2 minus integral of dx will be x plus the constant of integration c. So let us try to simplify this one. 1 by 2 in the denominator, when it comes to the numerator it becomes 2 by 1, which is 2 tan of x by 2 minus of x plus c. That is the required solution. The next question is, find the general solution of the differential equation dy by dx is equals to square root of 4 minus of y square, where the value of y is lying between minus 2 to plus 2. So we have the differential equation dy by dx is equals to a root of 4 minus of y square. So let us try to separate the variables. This root of 4 minus of y square is in terms of y. So let us try to take along with this y value. So I'll just try to cross multiply this one, retaining this dy as it is. Cross multiply this one, it becomes divided by root of 4 minus of y square. I'll just try to send this dx on the other side, we'll be getting is equals to dx. So you can see that the variables are separated over here. Y is on the left hand side and x is on the right hand side. Now we can integrate on both the sides. So if you try to integrate on both sides, we get integral of dy by a root of 4 minus of y square is equals to, it is integral of dx. You can rewrite this value as integral of dy by, this 4 can be written as 2 square minus of y square is equals to, it is integral of dx. So we know the standard formula, integral of dx by a root of a square minus of x square is nothing but sine inverse of x by a plus the constant of integration c. So if you try to observe here in this problem, the value of a that we have, a is 2 in place of a, and x value is what? X value is y. So I will be getting the value to be equals to sine inverse of x by a, x value is y by a value is 2, sine inverse of y by 2 is equals to, this integral of dx will be x plus the constant of integration c. So that is the required solution. We can further send this sine inverse on the other side, it becomes y by 2 is equals to, sine inverse when it goes on the other side it becomes sine of x plus c. Or you just try to cross multiply this 2 on the other side, y will be equals to 2 times of sine of x plus c. That's the required solution. The next question is, find the general solution of the differential equation dy by dx plus y is equals to 1, where y is not equals to 1. Given the differential equation, dy by dx plus y is equals to 1. So we can rewrite this as dy by dx is equals to, send this y on the other side, plus y will become minus of y. Now this expression is in the form of y, so group this y with this dy. So dy as it is, send this 1 minus of y on the other side, is divided by 1 minus of y is equals to, cross multiply the dx on the other side becomes equals to dx. Now you can see that this equation is in the variable separable form, therefore you can integrate on both the sides. So if you try to integrate on both the sides, we get dy by 1 minus of y is equals to, it is integral of dx. Now the left hand side is just in the form of dx by x, and we know that integral of dx by x is nothing but log of mod x plus the constant of integration c. Therefore here this will be log of mod of what value? 1 minus of y. That will be equals to integral of dx will be x plus the constant of integration c. That is the required solution. If you like my video, please subscribe to my channel. That's all I have for today. Thank you.